You where the camera is. Are you kidding me? You didn't tell you where the camera is? Yeah, it's like, you know, having a camera on the house mounted to look at the burglars coming in, and the guy sees the camera. Hello, spray can. Got you. I got you right there. What? What? No, I don't want Oreos from you, dude. Okay, listen up. What is C equal to? Yo, shut up. 0. What's f of C equal to? 1. What's f prime of C equal to? Can you take these quantities and shove it in this equation here? So then you get f star of x equals 1 plus 1 times x minus. Isn't that what we came up with? No, whoa. C is a specific point. Specific point. X is a generic point everywhere. Everywhere there be X. You guys with me on this? Huh? I'm scaring you guys? Good. That's the whole intention, man. I'm like coach. Doesn't coach kick your ass? What? Isn't coach hard on you? Oh, what? Tell me what? He's not? She's not? Well, come on, be honest. Like telling you, hey, you better speed up or else I'm going to cut you. I mean, isn't that what they tell you? Isn't that what the coach tells you? If you don't improve your time by a tenth of a second, you're not going to make it. Well, if the math teacher tells you, then you start crying. Okay, do you guys get this? Okay, so really what you want to go away with is this equation here, okay? That equation is called the linear, that equation is called the linear approximation to a function. Okay, so can you write that down? Linear approximation to a function. Sabrina, write it, to a function. From the point 0, 1, yes. Why are we learning that? We shall see in a minute. Okay, so I'm going to stop here and wait for you to copy this down, okay? It's, as you can see, it's pretty involved, okay? It's pretty involved. So, if you don't get it perfectly, I'm okay, because if you know, this is on YouTube. Go take a look at YouTube, pause it, and then get the picture, okay? All right, so what differentials let you do is they let you approximate the change in the function as you move from a given point. So you are given this point, c, fc, and you change it to being this point here, c plus delta x times all that nonsense that's there. Okay? So you start out at this point and you say, okay, I know what the function value is. I want to approximate what the function value is here. Okay? And what you do is, instead of using this line here, this dark line here, you use this tangent line to get an approximation. You use this tangent line to get an approximation. Because remember, the tangent line is a line. And a line is a simple equation, isn't it? Like x plus 1. I mean, compare that to 1 plus sine x. Isn't 1 plus sine x a much more complicated function? Isn't it? Okay? To evaluate that function, you will really need to use a calculator. But if you wanted to plug a value in for x in x plus 1, that's easy. Isn't it? Right? If x was 0.01, you just add 0.01 to 1 and you got an answer 1.01. As compared to putting it in 1 plus sine 0.01. To get sine 0.01, you need a calculator. So it's no longer a back of the envelope calculation. Okay? It's something that you need more fancy stuff with. Okay? So look at the notation here, okay, what I'm saying. So you start out at this point, okay? You want to approximate what the function is going to be when you go to this point. And I'm saying the way you do that is by looking at the x value being the same, see the x value is the same for both the dark graph and the straight line. The straight line is your tangent line. Okay, the straight line is your tangent line. So I'm saying that the x value there is the same as there. So my claim is that the y value on this tangent line is very close to the y value on this graph. Okay? So in other words, this y value here is an approximation to that y value there. Okay? You guys with me on that? All right. Let's go on to... Sure.
So when you're doing the stuff before, that's just like, that's the graph showing.
The stuff that we were doing before was writing this equation for this dotted line here.
Okay.
Yeah.
To get as close as we can.
To find an approximation.
So like,
To find an estimation. Sorry?
on our graphic calculator, I don't understand how we can zoom in and out to see that.
How you can zoom in? Oh, you can. Yeah, you should be able to.
Is that what she did?
Yeah. Well, no, this is on a different application. This is not a graphic calculator.
That's how you check it.
Yeah. Yeah.
So you just keep zooming in until where you think it is.
Mm-hmm. Okay. The next slide is all about notation and definitions. Okay. It's all about notations and definitions. Okay, so again, another pretty busy slide. I'm going to stop here. And the red stuff is called dy. Okay? Delta y is the actual